we are Linda and Mutlu. I think I pointed at you there. Linda and Mutlu, just to clarify. And we are both senior cloud solution architects who've been working with our customers and our partners on some of the end-to-end AI use cases. So Mutlu will go through some of his experience, and he will level set us on some of the basic tooling that the new version of which we're going to be using in these engagements. And I will then build on that, on how I've been using some of that with our customers in environmental sustainability use cases, which gives us one horizontal slice through a whole set of tool sets. So with that, I leave the stage to Mutlu, and I'll come and join you again in 15 minutes or so.
Thank you, Linda.
Thanks.
See you soon. Hi. Today, I'm really excited to be here amongst you at Build 2022. I am going to talk about some of the recent Azure ML-related updates, but also will mention about the implications of these updates for the developer community. I'll start with the new Azure CLI, our command line interface, and its machine learning extension, how it's going to change the way we do machine learning, together with the other features recently updated, such as MLflow integration with Azure ML, environments components of Azure ML, and then I'll give you a couple of examples from the pharma industry to show how these new features are being utilized. Finally, I'll talk about our new AI-based pair programming companion, GitHub Copilot. Let's begin. The CLI Custom, the command line interface for Azure has existed for a while now. It essentially allows you to interact with Azure services from the convenience of your terminal window, whether you are sitting in front of your Windows machine, Linux, or Mac. It gives you this scalability and flexibility to connect to Azure services. You can script whatever you want to do with Azure and put it in a CI/CD pipeline. Thereby, you can do things at scale easily, faster. Now, this Azure CLI had already an Azure ML extension, specifically allowing us to interact with the machine learning service. And it already allowed us to create, provision Azure machine learning instances, workspaces. It allowed us to submit pipeline runs. So what's the big deal now? Before I tell you about that, let me take one step back and tell you more about Azure Machine Learning. Azure Machine Learning is a PaaS service on Azure that allows you to create machine learning models and also to deploy these built machine learning models conveniently. It allows us to use different options to achieve the same goal. AutoML is essentially a functionality within Azure ML that allows developers, data scientists, data engineers to upload a data set to do things like classification, regression, forecasting. You upload a data set, you say that this is going to be my target variable, and then AutoML does the rest. It scans hundreds of different algorithms for you, ranks them according to performance, and then gives you the top performing algorithms as models ready to be deployed. The second method we have is the designer interface, which is essentially a canvas allowing you to drag and drop existing components so that you can create your own pipeline, a multi-step pipeline such as the one shown here. The third method is to do everything by code yourself. Either you start from scratch or you build on top of existing code. The caveat here is you need to also think about the dependencies of your steps, software dependencies, which Python modules you need in every single step, and what compute target you are going to use so that you make the pipeline run more efficient. Some steps may require GPU clusters. Some steps are going to be simpler and may run on a very simple cluster. And the way to do that was to use the Azure SDK for ML, which is a Python SDK. And that meant that you needed to do this data science part of the code as well as this extra task of provisioning compute clusters, dealing with the environment. Now, with this update, we are separating these two tasks. What you'll be able to do is you write your code on your laptop and run it on Azure as is, without having to do the extra bits for I want to create this cluster, I'll set up a Docker for this step. These complexities can be hidden in a YAML configuration file, and I'll show you how to do that. But first, let me go over these 3 additional updates we made. MLflow, which is an open source framework for managing the lifecycle of machine learning models, is now fully integrated with Azure ML. It also allows you to log your parameters metrics centrally as you are doing your experiments. It's fully integrated with Azure, and I'll show you how we can use it in conjunction with the CLI. Azure ML environments refer to a custom Docker environment or a given environment by the Azure ML service, which you can leverage in subsequent pipelines and projects without having to recreate the same environment again and again. You create it once, you specify your Python dependencies, and you use it, reuse it. Here we are really encouraging the reusability of your code as much as possible. And similarly, components are reusable steps of a pipeline that you can and your colleagues can use in different projects. Components are analogous in a sense to a function in that they have a name, they take input, they have parameters that you can change, and they return an output. And they correspond to a single pipeline in a complex machine learning, they correspond to a single step in a complex machine learning pipeline. Right, so let's see in this demo how we can put all of these together. This is a very simple Python script that demonstrates the use of MLflow. There is no Azure code in this simple Python script. Here I want to log a parameter called Microsoft build here, and the value is 2022, and a hello metric, which is going to be a randomly generated number. I also want to create a text file that contains the words hello world, and I want to save it as an artifact as part of my experiment in Azure ML for increased auditability traceability. MLflow allows me to do that very conveniently. And now this is the YAML file that I'm going to use to wrap the code. I'm specifying that this YAML is a command. The command is python hello mlflow.py. It's available in the source directory src. It uses this environment, which is a Docker image that pre-exists in Azure ML, and I'm telling it to use a cluster called CPU cluster. And now I go back to the command line. I use the AZ CLI. I make sure the ML extension is already installed, and as long as the version is about 2.3, we are good to go. Then I use the subcommands of ML job create to submit the YAML, and as soon as I do that, it will upload my Python script onto Azure from my laptop. And as you see, the status is now starting. If we go to the portal, we'll see that the CPU cluster is being provisioned. And checking the experiment details, we'll see that it's being finalized, and after a refresh, it's completed. Now we can check the output folder. It's our very own hello world.txt that we intended to create. It's now available forever as part of this experiment as an artifact, alongside the hello metric that we recorded and the parameters that we want to include also as well as the automatically generated metadata about who created this experiment at what time and so on. So what if now we want to create a more complex multi-step pipeline? We go back to the YAML. This time we say, instead of a single command, the type is going to be pipeline. And instead of a single Python script, I'm going to include 3 components in it. Each component is a separate YAML file, which can have its own Python script, environment, and compute target. It gives you the full flexibility of how you are going to construct your pipeline. And in this case, it's, again, a very simple Python script that does nothing but printing hello world. And you submit it in the same way. And here is our 3-step pipeline shown on Azure ML that we created totally in our laptop, in our local environment. So this flexibility gives you the power to run non-Python code if you want. If you are an R programmer, Java programmer, then just create a Docker image that contains the dependencies, and as long as you adhere to the principles of how this system works, you can do even non-machine learning related pipelines. We are not restricting you to just do ML, right? It can be about anything. So the code that you need to develop does not have to be developed in a notebook in Azure ML. It can be done in VS Code using the Azure ML extension. But there is another cool feature that I want to demonstrate, which is the GitHub Copilot extension that is available to VS Code users. It is essentially our AI-based pair programming companion. Let's say I am not familiar with MLflow. I mentioned it earlier. But I still want to use it. And what I can do is I express my intent, right, as a command in the Python script, and it does the coding for me. I tell it to create a random number and to log it, and it does so. I can do more complex things, create a text file, and then log it. It can do it. I can say, create a function that computes Fahrenheit degrees from Celsius, and it will do it. You can, of course, check whether it's accurate and so on, but it's very convenient. It speeds up the whole process, making coding much faster and efficient. And it's context aware. It knows that it created this function. It can reuse a function that was previously created. So let me finish by a couple of examples from the pharma, from our strategic partner GSK, in terms of how they are using Azure ML. Azure ML has been used by GSK for a very long time now, and these are very 2 recent examples. GSK Consumer Health wanted to create a machine learning model to forecast influenza-like diseases, and they wanted to automate the end-to-end process, so they started to work with MLflow, YAML, Azure DevOps, so that they can automate the end-to-end process easily. In a separate bioimaging project, GSK utilized Azure ML pipelines, and the intention was to do cell line characterization using fluorescence images produced by a lab microscope. So they created a special environment according to the software requirements they had, and they are now using the same environment no matter how many pipelines they have, and they are remotely accessing the pipeline by triggering it from a UI so that they can process hundreds of images in parallel. It reduced the time required for them, and it brought out of efficiency and reduced their costs, because they can choose between GPU and CPU clusters accordingly based on which step they are running. Thank you very much.